Hello my dear students. In continuation of our question series from Neet examination, today we will discuss the questions from the topic instantaneous velocity and speed. In the previous lecture we have discussed about the average velocity and speed, and in this lecture we will discuss the questions from the topic instantaneous velocity and speed. Okay, so let's start today's class with the first question. The first question says the displacement time graph of two moving particle making an angle 30 degree and 45 degree with x-axis shown below. We are provided within graph. On y-axis there is displacement, on x-axis there is time. Okay, for two objects, one object is making angle 30 degree and other is making angle 45 degree. We have to calculate the ratio of velocity. Okay, now from graph we know the slope of a graph is always given as y component upon x component, and the other formula is tan theta. Okay, if there is no concern of angle, then we use this formula, and if the angle is given, then we use slope is equal to tan theta. Okay, now in this graph y component upon x component gives displacement upon time. Displacement upon time. So displacement upon time is actually the formula for velocity. Okay, now the for velocity is dependent on the value of tan theta. So if we have to calculate the value of velocity, we just have to calculate the tan of angle. So according to the question, the ratio of velocities will be, so we have to calculate v1 upon v2. So the first velocity comes out to be, velocity depend on tan theta, v1 is equal to tan theta and v2 is equal to tan 45. v1 upon v2, putting the value of tan 30 and tan 45, we get 1 is to root 3. That is our required option number D. Okay, simply. And if it is not concerned of the angle, then the formula used will be y component upon x component. Going to the next question. The next question says two cars P and Q start from a point at the same time in a straight line and their positions are represented by, two cars are there, first name is P and other name is Q. The position for P is given by this equation and the position for Q is given by this equation. Okay, now at what time do the cars have the same velocity? Okay, we have to predict the value of time where the velocity is same. So we know x is actually position, differentiation of x gives us the velocity, and the differentiation of velocity gives us the acceleration. So in this numerical, the question is about same velocity. So we have to differentiate the position and hence calculate the time. Okay, so first position of car P is given by xp is equal to at square plus bt square. For calculating velocity, we have to differentiate the position. For differentiation with respect to t, at becomes a, because differentiation of t with respect to t gives 1, and bt square gives b as a constant and t square becomes 2t. Okay, by just using the simple formula for differentiation. Similarly, the position for q is given by this formula. Now the velocity for q is the differentiation of a position of q. Position of q is ft. Differentiation of ft gives f minus t square. Differentiation gives 2t. Okay, so we have calculated the position of P and we have calculated the position of Q. Now according to the question, at what time the cars have the same velocity? So we will equate both the positions, Vp, both the velocity Vp and Vq. We equate both the velocities, and solving for t, we get t is equal to f minus a upon 2 1 plus b. That is our required option number D. Okay, this is simply the application of directive differentiation principle. This is our position, this is our velocity, and this is our acceleration. Okay, according to the question, the velocities are equal, so we have equated both the velocities p and q, and after solving for t, we get f minus a upon 2 1 plus b. Okay, moving to the next question. The next question says if the velocity of a particle v is equal to at plus bt square, okay, where small t is time in second and a and b are constant, okay, then the distance traveled by between 1 second and the 2 second. We have to calculate the distance traveled between 1 second and 2 second. Okay, so according to the question, the velocity is given as at plus bt square. Okay, now if s is the distance and v is velocity, so v is equal to ds upon dt. Okay, now if we have to calculate s, okay, so we can write s as an integration of v dt, yes or no? Because differentiation or integrations are related to each other in this format. If we have to calculate s, then we have to send the differentiation in this side. When differentiation goes on the other side, it converts into integration. So s is nothing but the integration of v dt. Okay, so in this question we are provided with velocity and we have to calculate the distance. So we have to move in this fashion, because we have to calculate distance from velocity. So velocity is given as at plus bt square. No, velocity is nothing but the differentiation of ds upon dt. Okay, if we have to calculate s, we have to put the differentiation on this side. When differentiation goes on the other side, it is converted into integration, or we can say integrating both sides. Integration of ds is equal to integration of this. So integration of ds comes to be s, and integration of at plus bt square. Integration of at means a, and t integration t square upon 2, plus integration of b t square is b, and for t square we are using t raised to power 3 upon 3. We are using the formula x ki power n is equal to x ki power n plus 1 upon n plus 1. This is the required formula for integration of x ki power n. In integration we are adding, and if this formula is for differentiation, we put n x raised to power n minus 1. Okay, so we have calculated the value of which distance. Okay, now according to question we have to calculate the distance between 1 second and 2 seconds. So in this equation, first we calculate the distance at t equal to 1, s t equal to 1. Okay, so put t equal to 1. On solving we get this equation. For s t equal to 2 we get this equation. Now this is the required distance at t equal to 1 second, and this is the required distance at t equal to 2 seconds. But according to the question we have to calculate the distance travelled between. Okay, distance travelled between 1 second and 2 seconds. So we just separate the distance travelled in 2 seconds minus the distance travelled in 1 second. So we get the difference between the 2 seconds. The required answer is 3 by 2a plus 7 by 3b. That is our required option number A. Okay, now moving to the next part. The next question says the displacement x in meter of a particle of mass small m in kg moving in one dimension under action of force is related to time is given. Okay, we are provided with the relation of time and displacement. T is equal to under root x plus 3. The displacement of the particle when its velocity is 0. We have to calculate the displacement when the velocity is 0. So firstly we have to convert this t equation in the form of x. Okay, so t is equal to root 3 plus x. Root x can be written as t minus 3. Okay, now for removing the concept of root we have to perform squaring. So squaring both sides we get x is equal to t minus 3 whole square. Okay, now this is our required x. For velocity we have to calculate dx upon dt. So the differentiation of t minus 3 comes to be 2t minus 3. Now we have to calculate the point where this velocity becomes 0. So we put this term equal to 0, 2t minus 3 equal to 0. Solving we get t equal to 3. Okay, 3 equal to 3 is that time in which the velocity is 0. So t equal to 3, x values comes out to be 0 meter. That is our option number B. We have to calculate the value of displacement when the velocity is 0. So we first calculate the velocity, then equate it to 0 and calculate the required time, and after calculating the required time we again put this value in the equation of x. So we get 0 meter. Okay, this is the required solution of this question. Now moving to the next question. The next question is the graphical representation of distance and time. The question says a particle shows the distance time graph as shown in figure. The maximum instantaneous velocity of the particle will be. We have to calculate the maximum instantaneous velocity. So for maximum instantaneous velocity the slope should be maximum or highest, and by observing point A, B and C, D we can see C is having the maximum slope. Okay, So why the C is having maximum loss? V is equal to ds upon dt, and we get maximum value. So the required answer is option number C. This is related to your topic of instantaneous velocity and speed. The next question is says the position x of a particle with respect to time is given by x equal to 90 square minus t cube, where x is in meter and t is in second. What will be the position of this particle when it achieves the maximum speed? Okay, so we are provided with the position x equal to 90 square minus t cube. Okay, we have to calculate we have to calculate the position when the speed is maximum. Okay, so first we have to calculate the speed. So speed is equal to differentiation of position, differentiation of 90 square minus t cube. 9t square comes to 2t. Okay, that is 18t, and t cube becomes 3t square. For we have calculated the speed, and for the maximum speed we know the differentiation of velocity must be equal to 0. For maximum speed, dv equal upon dt is equal to 0 using the concept of maxima and minima. Okay, so we put this value equal to 0, t comes out to be 3. Okay, so 3 seconds is the time in which the speed is maximum. Now according to the question, we does not have to calculate the maximum speed, we have to calculate the position at which the speed is maximum. So the equation of position is this. So we put t equal to 3, we get 54 meter. That is our required option number A. Okay, moving to the next part. The question says a particle moves along a straight line OX at time t in second. The distance x in meter of the particle is given by, the equation for distance is this. Okay, how long would the particle would travel before coming to rest? Okay, how long the particle will travel before coming to rest? Okay, we have to calculate the length or the distance when the particle comes to rest. Okay, so the equation of position is given as this. We can calculate velocity as dx upon dt. 40 becomes 0, 12t becomes 12, and minus t cube becomes minus 3t square. Okay, now according to the question, the particle comes to rest. The particle comes to rest means velocity becomes 0. So we put this velocity equal to 0 and calculate the time, that is equal to 2 seconds. 2 seconds is the required time when the velocity becomes 0, or we can say particle is at rest. Okay, now we have to calculate the distance traveled before coming to the rest. So distance is nothing, integration of ds is equal to integration of v dt, and according to the question, in 2 seconds it comes to rest. So the initial time is 0 and final time is 2, and the distance is initially 0 and final is s. And solving for s, we get s is equal to 0 to 2, 12 minus 3t square. Now integrating, 12 becomes 12t and minus 3t square become minus 3, and for t square we get t cube by 3. Applying limit 0 to 2 and solving, we get 16 meter. Okay, that is our required option number A. Moving to the next part, the next question says the displacement x of a particle vary with the time x equal to a e raised to power minus alpha t plus b e raised to power beta t. A, b, alpha, beta are the positive constant. We have to calculate the velocity. We have to predict the velocity. Now x is actually the displacement, and velocity we can calculate by differentiation of displacement, and differentiate dx upon dt means we are differentiating with respect to t. So a is constant, it will be as it is. E raised to power minus alpha t will be same, and minus alpha will be in the forward. So minus alpha is this according to the rules of differentiation, and b e raised to power beta t, b beta, and the power beta comes in forward. Okay, this is the value for which velocity we have calculated a velocity from displacement. Now we have to predict the velocity of the particle will be. So we can say according to this term the velocity will increase with time. Okay, so there is a positive relation according to this. We can say velocity will be increased with the time. Okay, moving to the next part, the question says the displacement time graph of a moving particle is shown in figure. We are provided with displacement time graph. We have to calculate the instantaneous velocity of the particle is negative. We have to predict at which point the instantaneous velocity is 0. The velocity is given by ds upon dt. Okay, so the instantaneous velocity will be negative when the slope is negative, and we can see the at point E is the instantaneous velocity negative. So the required answer is option number A. Okay. Moving to the next question. The question says, which one of the following curve does not represent one-dimensional motion? Which does not represent? So by observing A, B, C, D and option, we can see in this graph we are having two values of velocity v1 and v2 at a fixed time interval, which is not possible. Okay, a particle can't have two velocities at the same point of time. So option number B does not represent a one-dimensional motion. Other option A, C and D represent 1D motion. So according to the question, which curve does not represent? Does not represent is option number B. Okay, because it shows two velocities at the same time, which is impossible. Okay, so this is all about the question and answer which have been asked from the topic instantaneous velocity and speed. In the next lecture, we will discuss some more questions from a particular topic so that you can enhance your preparation and be confident in a particular topic. Thank you.